notation today. Does anybody recognize this quote? What's in a name? That which we call a rose by any other name would smell less sweet. Now tell me where it comes from. Yeah, what is that? What's Romeo and Juliet?
A play.
A play by Shakespeare, right? Which love story? The love story. And so, do we know? Does anybody know that briefly? What's that story, Romeo and Juliet? Oh, sure, give me the ending.
They're pretending to see each
Well,
other.
what's the problem?
They're both different, like.
Are we talking about Romeo?
Romeo and
Juliet. It's the story, right? Quiet. What's going on with Romeo and Juliet is there are two young people, right? They love each other, am I right?
Yeah.
But they come from families who hate each other.
Yeah.
So their families say they can't see each other. So she says, what's in a name? That which we call a rose by any other name is so sweet, right? So a name, what is a name? If his name wasn't Romeo and he was somebody else, he would choose Fifth, then the family would be fine with it. So what's in a name? Can we call things by different names, but they're still the same thing, right? And that's what we're getting at here. Because with functions, we're going to use some notation. And I don't want you to get all confused by it because it's the same thing, but we're just calling it something else, right? New ways of referring to functions. So another way to name them, this is what we know. Y equals 2x plus 1. Now, x is our input, right? And y is our output. So we're not going to change it drastically. This part's the same. X is our input. But instead of saying y, I'm going to call it f of x. And f of x is the output. And that is how you say it, f of x, how we pronounce it. And what this means is, instead of just saying everything is x and y, I want to name my functions. I don't want them all to be just y. I want this one to be called f. Now I could use other names. I could have called it g of x or h of x. It's a way of giving different names. We'll see why in a moment. X is still x. It's saying this function g or this function h or this function f has as inputs x. That's all it means. Now it just says if you put in x, f of x is your output, just like y is your output. Y and f of x mean the same thing. Okay? So when I make x, y tables, right, when we're doing table of values, you could also call them x, f of x tables. They mean the same thing. You do the exact same thing. -2, if f of x is 2x plus 1, and I put a -2 here, you put a -2 here. 2 times -2 is -4, plus 1 is -3, just like you would do here. So it's not different other than how we refer to it. Okay? Stay with me here. And the y, somebody said y right away, which is a good question. So let's keep looking. So the good news, everything works the same as when you say y equal. Domain is still the set of inputs. Range is still the set of outputs. You graph everything exactly the same way. You use table values. You can still use intercepts. Everything's the same. Instead of saying y equals, I'm saying f of x equals, or g of x or h of x, whatever I'm calling my function. Why? One reason is, let's say I have a bunch of different lines all in the same graph. How do you know which one I'm talking about? Well, this one's f of x, and this one's g of x, and this one's h of x. Imagine if all of you, well, it's almost true that we all almost have the same name. I've got like 3 Ryans in this room, don't I? So that's confusing. So by giving people different names, or now I say, well, that one's Ryan N, and that one's Ryan S, and that one's Ryan Y, right? So I have to differentiate so I can tell, well, Y, you are, I know. Okay, so it helps me know which person I'm talking about. Giving them different names helps me know which function I'm talking about. Another really good thing about it is it tells me what the input is. This one says you have a function f, its input is x. Look at this one. Some function called h has an input of t. So that's a graph that, this is t, and this is h of t. So it's another way of saying inputs and outputs. Okay? That's all it is. you can do cool things with this now that you can't do with plain ordinary y equals. So if I have a function f of x equals 3x minus 15, right? Same thing as if I said y equals 3x minus 15. But I have a new way of saying, I want the input to be 3. Now before we were kind of saying, well, I don't know how to do that. Maybe I'll make a table and put a 3 here. Right? Doesn't that mean the input is 3? Well, now I can say, for function f, use input 3. And how does that work? So here's f of x. It's 3x minus 15. So now I'm taking the 3. So what am I going to replace with 3? The x. Wherever you see an x, you put a 3 in. Yeah. So what is f of 3? You put a 3 in wherever there's an x. That's 9 minus 15, which is negative 6. Does that make sense to you? Right? How about what's f of 10? How would I find f of 10 if this is f of x? Ryan, what would I do? Yeah, so what should I write here? Equals what? 3 times. And that equals 30 minus 15 equals 15. So f of 10 equals 15. Any other questions? Here, this is my function rule. Right? They're giving me what f of x, what the equation is, and then f of 3, plug in a 3. F of 10, plug in a 10. What's f of negative 1? So 3 times negative 1 minus 15. Negative 3 minus 15, negative 18. Question? How do I find what the f is? Well, it's the same, you're telling me. It's like saying grandma equals this goal right here. So f of x is this function right here. Yeah.
So when we're getting questions, they'll give us like f equals, and then maybe we find
Yeah. It's just like saying here's y. Y equals 3x minus 15. What's y when x is 3? It's the same thing, simple way of saying it though. That's all. Yeah. What do you mean? Why am I putting the 14 in here? Here? Because it's 3x minus 15. So I plugged in my 3. That equals 9 minus 15 equals negative 6. I'm just evaluating at x is 3. Yeah, this one. Now think about this now. Hang on. So let's say f of 10 equals 15. So 10, right, that's the x. When you take the function out, you get this. Think about what the ordered pair is that's represented here. Can I write an ordered pair based on f of 10 equals 15? What's the x? And what's the y? 15. Yeah. Input, output. Yeah, so you can look at these and you can write, okay, f of, f of negative 1 equals negative 18. What ordered pair is represented here? Yeah. That's all it is. X, Y. Yeah, go ahead.
Okay, so basically you just plug in X.
Yes. 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 Basically, you just plug in the X. Yes. It's like saying, can you choose whatever you want for Y? So normally they will give you a function for whatever reason, and you have to find some. This is like, well, they want to graph this. So find f of 0, find f of 1, 5, and f of 2, and then graph. It's another way of saying everything you've already done. So it's not like this is so new. It's just another way of saying everything you've already done. It really is. And he's right. You just plug the x in. Yes. That's what you do. Now, we can think about it another way. Now, when we were solving for x-intercept, remember when we solved for x-intercept, you had to set the y equal to 0? Well, remember y is like our output. Y is now the same as f of x. So sometimes we're going the other way. This way, I'm giving you an x, I want you to find the y. Now I'm giving you a y, and I want you to find the x. So, here's an example. It's on here someplace. I got one paper here. Let me get there. Okay, so if f of x is 2x minus 10, find x. That I don't know this, so I'm not just plugging in something. Find x such that f of x, which is another name for y, right, equals 6. So basically, you know your output, find your input. I hear a lot of talking, you with me? So how does that work? If f of x is 2x minus 10, and f of x is also 6, why did I put the 6 here?
Because F, what is the F of X?
Equals.
Substitution, right?
Yeah.
F of x and 6 are the same thing. It's like saying y equals 2x minus 10 and y equals 6. Let me just put the y here, 6 here. That's what I'm doing. How do you find the x? You solve an equation. So 6 equals 2x minus 10. You add 10. And you divide by 2. X equals 8. So what did I just find? When f of x equals 6, x equals 8. Another way to say that is f of a equals 6. X is 8, y is 6. Nobody follows that at all?
I did.
Okay, all right, now I got 2 people. Let's see, I think I got another example here. Oh, find x such that f of x equals 0. Does this say plug 0 in whenever you see an x? What would that be? That would be f of 0. Do you see the difference between this and this? This one is saying y is 0. This one is saying x is 0. So if this is my function, f of x equals 2x minus 10, and f of x equals 0, where does the 0 go? Then where does the 0 go? What? At the where? I have 10. I have, oh yes I do, 2x minus 10, but it's, that 10's a number. I'm not going to replace that. Where does the 0 go if f of x is 0? Easy, what do you think? Why is it not this x? Why is it not that x, Danny? Yeah, I didn't say x is 0. Look at the difference between this statement and this statement. X is 0 says put the x 0 here. F of x is 0. Where's f of x? Here. This thing is 0. And that's what gets replaced. So if x is 0, it goes here. If f of x is 0, it replaces f of x. Solve this equation. And we get this. Divide by 2 and a little symmetric property equality, x is 5. F of 5 equals 0. Because that's the x, that's the y. This is also x, y. X, y. Oh, wait a second, what's that? That looks familiar. The x-intercept. That's how you find the x-intercept. You set the function equal to 0. We have another name for that called the 0 of a function. 0 of a function. Okay? A 0 of a function. We talked about this briefly last time. A 0 of a function, talking about just new terms, it's the x-intercept. It tells you where the function, where the f of x or the y equals 0. That would be here. This is called the 0 of the function. Set the function equals 0. Okay, let's find the zeros of the function. You just look at it, right? Look at a graph and look for an x-intercept and you found the 0 of the function. So this one is 2, 0. Isn't it? What's the zeros of the function here? We don't even know what this thing is. What are the zeros or where are they? Yeah, Connor? Yeah? And? This one has 2. Has 2 places. So this one has zeros of -2 and 0. This one just has 1 and -2. You're looking at the x-intercepts. Now you can also find them algebraically. I know when you look at these values here, what's the y value of these points?
0.
0. The y value is 0. So set f of x equals 0 because f of x and y mean the same thing and solve it for x. So that's what we did here. You said the function. X minus 2. If you want to find the zeros, set the f of x equals 0. Solve the equation for x. X equals I'm gonna be saying this over and over and over. For some, it's not that it's so hard, but it just takes that little sink in time. So if ever I'm talking about zeros and ones, you say, what? I want you to ask me. Don't be afraid to ask me, even if it's like the 10th time. We've got a couple of new tries. I just want to do a few together just to make sure we're kind of recap here. So if f of x is negative 7x, how do you find f of 7? Danny, how would I do that? Yes. So f of 7 equals negative 7 times 7. Because we already filled in that one. Now put it here. So what's f of 7? Negative 49. Give me what? Who's got a question?
It was Matthew that said that.
What? What's the question, Matthew? Come on, ask it, ask it. Come on now. My question is,
Matthew.
what? That's my question.
He just doesn't get it.
F of x equals, so you have to look at the notation. What got replaced? X. So replace x. Matthew, g of x is 12x plus 1. How do I find g of negative 2? What got replaced here? X became a negative 2. So x needs to become a negative 2 there as well. So that's negative 24 plus 1. I'm going to leave these two for you. Now the other side of the coin is this. F of x is 6x minus 6. Find x. So did they give you x?
No.
What are they giving you?
The Y.
F of x, the y. So where does the 24 go? Where's the 24? Into the f of x. 24 equals 6x minus 6. Now you've got an equation to solve. And over here, 30 equals 6x. Divide both sides by 6. Symmetric property of equality. See, when x is 5, f of x will be 24. What would be the x right there? 10? What's your y value, your output? Question?
I'm confused about the difference between the one that
This one, I'm giving you x. I'm giving you an input. Find an output. Now, we used to say find an output means find y, and it still does. But we can also say that means f of x. This is and y are the same thing. Well, none of us knows we, yes, I call it anything else. So now, given this one now, I'm giving you an, say something wrong, we should say input. Wow. Give an input. So now I'm giving you an output. I'm giving you the y value. I'm giving you the f of x value. Find the input.
So if you so on the other one, did you say F and
No, it tells you what to say. F of x is 24. Look at this one. F of x is 7x plus 3. F of x is 17. Where does the 17 go? Yes. So substitute what you see. Solve f of x. Substitute. This one is giving you an x, so plug it in. All right, try the other two. Try, all right. You had a little time to work with this. H of 0 says x is 0 plus x. Negative 8 times 0 is gone, right? Minus 2. So h of 0 is negative 2. P of 2, you're plugging your 2 in here. So you have to know how to take the roots of 2. And 2's cancel out. Negative 3 plus 5 is 2. That's when you have replacing the input. These are replacing the output. Now what does it mean to find the 0 of a function? Zeros are x-intercepts. Remember what those look like? So your y value, your output value is 0. So you're going to set this thing to 0 and solve the equation. Add 8 to both sides. So 4x equals 8. So x equals 2. That's your calculus. This guy, find the 0. So Ryan, what am I going to do to find the 0? No, this guy becomes 0. Your output is 0 because a 0 is an x-intercept. That means your y value or your output value is 0. Questions? Let's see, we subtract 3, and then you divide by 7, x equals 2. Let's do it. How would we do it? No, you gotta subtract. Can't add 3. If you do that, you get 7x plus 6 equals 23. You have to subtract the 3 away. Alrighty. Okay, that's topic 1. Here's topic 2. Now, topic, I'm not even doing the challenge. I'm skipping the challenge for this. I'm skipping the challenge. We don't need a challenge. Let's do the easy first. Okay, literal equations. Now, we talked about literal equations when we talked about standard forms. You guys remember standard form? Yeah? No? Yeah. AX plus BY equals C. Linear equations, right? There's really only 2 variables here. It's a model showing if you have something that kind of looks like that, I can find A, B, and C. And we use literal equations a lot in formulas. So we solve for these different things. Now the letters and coefficients here are not really the variables. They're just showing a pattern. So this one, your A is 4. Ooh, what's my B? If AX plus BY equals C, I have a negative. What is it? Negative 3. And what's my C? 10, right? So these are literal equations. Think about formulas, right? We use those all the time. So here's some examples. Anybody 8th grade physics here? Remember my 8th graders? Did they give you that little triangle thing?
Yeah.
How does that work? D and MV, like where?
Like density, mass.
Yeah, like where's the D go? Where's that? Where do you put stuff? Is the D up here?
Yep, here. And then
Okay, that's this, right? And then you're supposed to remember all the stuff from this. So D equals M over D.
No, dude, it's M on top.
Is it M on top too? Because I don't know. I don't use this. So who gave you this? Is this Miss Orr? Who gave you this?
Miss Luca.
Miss Luca? Okay. You're gonna go tell the Miss Grieser said I shouldn't be using your triangle. They'll be coming to see me, believe me. Now why not? You don't need it. And we're gonna learn today why you don't need it. Remember one of them, and you can find the other ones using mathematics, which is why we have mathematics. Okay. So say we got force equals mass times acceleration. You guys learned about that?
Yeah.
No. 8th grade?
Yeah.
Okay. 7th grade too. All right. Well, it does. So now let's suppose I know the force and I know the acceleration. I want to figure out the mass. So if you guys really get how to do equation solving, this is not hard. How do I get n by itself here? What if this had said 10 equals m times 2? What would you do to get n by itself? Okay. So what should I do here to get n by itself? What's A over A? A isn't 0? No. What's 2 over 2? So as long as A isn't 0, what's A over A? 1. So that means M equals F over A. Yeah. So now I've solved it the other way. Let's try a different one. F equals MA. Let's say I know force and I know mass, but I want to find acceleration. How would I get acceleration all by itself? Yeah, what'd you do? Yeah, divide by M. Because what's M over M? 1. So A equals M. So you see why you don't do that little triangle? As long as we know one thing, so what is the density? What's the equation? I don't know what it is.
density equals mass by volume.
Is that right? Yeah. Okay, so you need a triangle. What if I want mass by itself? How do I get rid of something in the denominator? Think about this. What if I had 10 equals m over 2? What do? Multiply by what? No. I want n by itself. Oh, multiply 2 both sides. Right? Isn't that what you do? Because these reduce. This is why if your equation solving is good, it's not so hard. So what am I going to do here to get m by itself? No. What did I do here? How did I get rid of the denominator? Multiply so that I can reduce it, right? Multiply both sides by V, so M equals volume times density, right? Isn't that that little triangle thing tells you?
Yeah.
You need that stupid triangle thing?
No.
No. Now what about V? What if I want V by itself? Well, first of all, multiply by V like we just did, and then how do I get V by itself? So V equals M over D, isn't that correct? Or is the triangle? You need the dumb triangle?
Well,
You need the triangle. No. Just remember one of them, you can find the others. Okay? Solving for a variable, mathematics. If you get equation solving, this will not be difficult. If you've been faking your way through equation solving, you're going to learn equation solving now, right? Because we use the property of equality. So, it's just like solving equations with numbers, except there are variables there. So let's look at some examples solving for y. Now, let me see where I am here. Yeah, okay, I'm on the middle of the page 2 here, so watch what I'm doing here. I want to rearrange equations so that I'm solving for one of the variables. And you can solve for x, you can solve for y. And by solving, when I'm all done, I want to see y equals. That's what solve for y equals. If I said solve for x, when I'm all done, I want to see x equals. What I do is I underline what I'm solving for. This one doesn't move, everything else does. Okay? So how does this work? So I want to isolate y just like any other equation. Oh, what does this say? Okay. So you say 4x plus 2y equals 8. Let me ask you a different question. If it just said 4 plus 2y equals 8, what would you do next? That's your question. If you were solving this equation, what would you do next? Okay. So, and that's to get this by itself. So what should I do here?
Subtract 4x.
Subtract 4x from both sides. Because what's 4x minus 4x?
0.
Okay, so when I'm over here and I've done that, what happens next? So what am I going to do here? Now be careful, dividing by 2. When you divide by 2 an equation, you know what gets divided by 2? Everything! What? Everything. Everything. See how everything is getting divided? Does that hurt anybody? Did I wake you up?
Yeah.
Good. Okay. Everything, everything, everything. So let's see what we got here. What's 2 over 2? So there's my y equals. What's 8 over 2? And what's that? Negative 4x over 2. Negative 2x. I've solved this equation for y. So you're doing all the steps you would do for numbers, except you got other variables in here. Now when you do solve for y, that's a special name. It's called putting it in function form. So if I give you something in standard form and I say put it in function form, I'm asking you to solve for y. Alrighty? Alright, so here's a couple more examples. Solve this literal equation, ax plus b equals c. And I'm on the examples here, we're getting towards the bottom here. Solve it for x. So here's what I do. So I underline the x. X isn't moving. Everything else is. So think about if this was numbers in here. What if it was 2x plus 3 equals 7? I don't know. What would you do next? So what am I going to do here? Subtract 3. So ax, b minus b is 1. What would you do here after you do that? Right? You put 7 minus 3. What would you do? Divide by 2. Now everything gets divided by 2, right? Another way to do that is one big line. Putting one big line is the same as putting a 7 over 2 and a 3 over 2. So if I want x by itself, what should I divide by? A. So I can make a big line here, which is the same as making two little lines. C over A minus B over A. What's A over A? So x equals C. I did it. I solved it for x.
Oh, that's actually
If you know how to solve an equation, it shouldn't be a big deal. If you've been thinking equation solving, big deal. They guess numbers. Oh, it is this one. All right, put this in function form. What does that mean? Solve for y. I want y equal when I'm done. I'm underlining that, so don't move this way. Who gets moved? Let's do it. Subtract 4x. I'm gonna do something different. I'm gonna put my 4x up front, only because in the future we're gonna need to. I can do this, right? So divide by 2. What is divided by 2?
Everything.
Everything. Y equals negative 2x plus 4. Solve for y. Alright, we put that away. We're running out of time. I'm gonna get this done. Oh, look at this thing. This is a formula for area of a triangle. So what if I know everything except h and I want to solve it for h? Oh, well, goodness gracious. First of all, think about how you get rid of a half. By what? 2. Reciprocal. So I multiply both sides by 2. So 2a equals, what's 2 times a half? 1. So now I'm just left with dh. Still solving for h. How do I get h by itself now? Divide y big. That's a big one. H equals 2a over b. Look at that. Whoa! Anybody's mind just go,
Yeah.
yeah?
There.
Yush? You're using the properties, put numbers in there for everything but x. Follow those same steps. Yes, sir.
For the area for the triangle, did you start
Yes. This one, this one's a little hard. I just watched this guy here. Am I solving for f? I think it was notice that multiplied by reciprocal, right? So I'm going to do that on both sides. So I have 9/5 c equals, well, that's the big one now. And then I add 32, right? So 9/5 c plus 32 is how you convert Celsius to Fahrenheit. I don't have to remember 2 formulas now. I only have to remember 1. And this is the big deal here. This is it. You're using the properties of equality to kind of play and manipulate different equations. So if you want to go ahead and try some of these U-tries, and I'll even have answers that we can check, do some of the simpler ones first and work your way down. I will say, if your equation solving is all based on, identical numbers, this is going to be hard. But if your equation solving is strong, it shouldn't be too bad after you try it a little bit. Okay? So give it a go, and I'm going to hand out my